likely in our previous question from yesterday's class, we did one question where we found the derivative of this rational function, which was negative x squared minus 2x plus 1 all over this, right? Now, I don't know if students remember this answer, how we arrived to that answer quickly or not, but don't worry, we'll practice that again. I just want to see if you're given a fraction here, and if you set the fraction equal to 0, this is what I'm more concerned about. When you have a fraction, what really matters? Is it the bottom or the top?
The top.
The top, right? I don't really care if the bottom is out of 10 marks, 100 marks, a billion marks. If you get 0 out of anything, that's always going to be a 0, right? So you're really focusing on the numerator being equal to 0. And now we have one of these classic quadratic equations. Some students want to factor out the minus sign, which is totally fine. Then how do I factor this quadratic here? Yeah, I don't think we can, right? All right, so what do we do in this case, class?
The quadratic formula.
We're going to use the quadratic formula, right?
Oh, nice.
We're going to use the quadratic formula, so we can't factor that. So for those students who remember the quadratic formula, what's the quadratic formula?
Negative b
plus or minus the square root of b squared minus 4ac.
Negative b. Oh my goodness, I feel like some students had that class where you sing that song, right? But negative b plus or minus square root of b squared minus 4ac divided by 2a.
Yeah. Is it Mr. Wong or Mr.
The good news is, if you have forgotten it, it's on your brand new formula sheet as well, right? So there you go, some justice finally. All right, so can someone help me? How do I plug in the numbers here? Maybe I'll just erase this one. And what's my b and a values here now?
We get plus 2.
So 2, yeah, plus or minus.
4.
Wait, why did you decide not to factor it?
Oh, we couldn't factor it.
No, why did you decide not to factor the negatives?
Because it's just easier to find the A, B, and C if I don't if I go back to this stuff here. So like this right here, Darcy, A is what, -1. This one is B is what, -2. And C equals to 1.
Yeah.
I just went back to that step because I think A, B, and C are easier in that form than the factor form. I gotta switch the signs back, I guess. Okay, so let's go ahead and kind of write out the numbers again. This would be negative b squared, so -2 all squared, minus 4 times -1 times 1. And then we have what, 2 times?
-2.
Right. And at this stage, class, I'm a little bit lazy here, so I don't really want to write out every single thing here. What do we have? Is it 4 plus what?
4.
Which is 8? All over -2. And I'm going to leave my final answer like that. I know you can simplify this a little bit more. If you want to simplify this a little bit more, it would be 2 plus or minus, should be 2 root 2. And if you want to divide that by -2 and then write your separate coordinates, that's totally fine. But I'll leave my final answer like that just because I'm a little bit lazy right now. So if you want to leave like that, I'll take that for full points because that answer there, I fully know what that means. The good news is we just asked for the x-coordinates. For that question, just the x-coordinates?
Yeah.
Right, so thank God we don't need to find the y-coordinates because that would take more work, so we'll leave our final answer like that. Okay, so that's great, just one little review of the quadratic formula. Now, what we're going to do in this class is I need to review the quotient rule a few times. And when do we apply the quotient rule when we're dealing with a what function? A rational function, or basically like something with a numerator and a denominator, right? Usually in our course it's a rational function, but sometimes we'll have functions that are not rational. But whenever you have this fractional expression, we can use the quotient rule. Now, if I go back to yesterday's class, the quotient rule is a little bit weird, right? It's the derivative of something on the top divided by something on the bottom. Hopefully they're polynomials, but if you read the language again, it's derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. very weird language, but we need to do this about 3 or 4 times before we get comfortable with it, right? So derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. The top is kind of like the product rule, right? Kind of like the product rule, except there's a minus sign in the middle. So we got to make sure we differentiate the top first, then times by the bottom, and then minus the top times the derivative of the bottom. So kind of similar like the product rule. Luckily, like that formula is on your formula sheet, so you don't need to memorize it. So let's go ahead and see if we can apply it to a problem like this. Is this a problem with a fraction in it? For sure, right? And there's no, you can factor the bottom, but the numerator doesn't factor nicely. And I want to find the slope of the tangent line at x equals to 2. Okay, so it's asking for the slope, right, when x equals to 2? Okay, so so basically what we're really asking to do in this question is I want to find q prime of 2, right? We want to find the slope when x equals to 2, right? All right, so since we have a fraction here, we need to take the derivative by applying the quotient rule. Let me circle the top here. And if you want to find the derivative, you would write q prime of x. And Shadi, what's the derivative of the top?
2x.
Yes, 2x. So that's becoming automatic, I see. And then we times this by the bottom. And Shadi, what's the bottom?
X cubed plus 1.
Right. So derivative of the top times the bottom. And then the rule says you need a minus sign. And then generally, I take the derivative of the bottom next. So what's the derivative of the bottom? Anyone? 3x squared, yeah. And then you just times it by the top. Yeah. And then at the very end, you just take the denominator and you just square it, right? And this is where I would tell students to stop. Yeah, so even if you're taking AP calculus like Lucas' boyfriend, I would tell them to stop right now. We don't simplify this. I would just plug in 2 next. Okay, so x equals to 2. So what are we doing next? We need to do what, q prime of 2? Right, so don't simplify this. I would just find all the x's, and anytime you see an x, you just change all those x's to what? 2. So the first box is okay. So 2 times 2 is 4. And what's 2 cubed? 8. 8 plus 1 is 9 minus. And what's 2 squared? 4. And what's 4 times 3? 12, yeah. And what's 2 squared?
4.
4 and 4 plus 1 is 5, right? So notice that you can do all that mental math in your head, right? If you foiled and simplified it, I think you would probably cause yourself more work. And then we just divide this by, what's 2 to the power of 3? 8, and 8 plus 1 is 9, and then 9 squared, right? So I would say, like, I do think, senior students can definitely do that mental math in their head. And maybe the next tough part is coming up here when we deal with these weird numbers here. 4 times 9 is what, 36?
Yep.
Minus, is it 60?
Yep.
All over 81. And what's on the top now?
24. Over 81.
81. And for sure, you can keep on simplifying this by dividing the top and bottom by 3. Any volunteers on that?
Negative 8 over.
Yeah. There you go. All right, so there it is, class. There is the quotient rule right there, and we're evaluating the quotient rule when x equals 2 to find the slope. And thanks again to whoever volunteered and said negative 8 over 27 is a final simplified answer there.
What about 2 to the 3 and 3?
Let's just stick with that. This is also fine with me. I'm not. If you want to stop there, that's also okay with me. I'm not so picky about simplifying numbers all the time. And there you go. Okay, so quotient rule is derivative of the top times the bottom minus the bottom times the derivative of the top divided by the bottom squared, right? So even though it's on your formula sheet, I do find that once you do enough of them, you'll probably memorize how to do it, and that's totally fine. Let's do a few more of these, and let's. And we're almost actually done this lesson. Actually, only 2 more examples. We're done the quotient rule here. For this function, I want to find the equation of the normal line. Okay, normal line.
That's like,
That's
isn't that
discriminatory.
like the negative reciprocal?
Yeah, there's a question in Math 10 where you have to find two equations of lines that are parallel to each other, and there's perpendicular as well.
Oh yeah.
Let me just remember that concept.
Yeah.
Okay, so if you have parallel lines, the slopes are the what?
Same.
Right. Back in Math 10, there was another concept where if the lines are perpendicular. So remember the relationship between the slopes when those 2 lines are perpendicular? So if this slope was, I don't know, 2, then what's this slope?
Negative 1/2.
Right. So if 2 slopes are supposed to be perpendicular, there's this a negative reciprocal relationship between the slope of one line and the other line. I would say that the normal line question is like 98% the same thing as the tangent line, and you just need to flip your answer at the very end. Okay, so even though it says normal line, it's 98% the same thing as finding the tangent line. Okay, so we'll fix that at the very end there, because I feel like some students may not remember the perpendicular line. And make a note, I would say it's 98% the same as tangent line. We'll talk a little bit about normal line just because it's just a little add-on question here. If you have to find the tangent line, I would start off by writing y minus what? y1 equals to m times that, right? So I don't even care what the function is. As soon as I see anything related to the tangent line, that's the first thing I'm going to write. And I recommend, class, is that you always go after the pre-calc or the grade 10 stuff first, because that stuff should be still fresh in our heads. And we know that f of x equals to the cube root of x plus 3 all over the cube root. Sorry, the square root of x plus 3 divided by the square root of x plus 1. And anytime we see an x here, the x's will change to what?
1.
Right. So the top is going to be 4, the bottom will be 2.
2.
Right. So class, what I recommend is you take your 1 and your 2 and plug that in first. So once again, it's 98% the same thing as the tangent line, and I would recommend taking care of the pre-calc stuff first, which is your x-coordinate and your y-coordinate. And then if you want to find the m value, which is called the derivative value in Calc 12, how do I find m now?
The quotient rule.
Yeah, we apply the quotient rule and we plug in 1, right? So we find y prime, we'll say f prime of 1, and then we'll do one more thing at the very end. Now, class, before we find the derivative here, I was wondering if I could write one more thing down here. Can we please write down f of x equals to x to the power of 1/2 plus 3 divided by x to the power of 1/2 plus 1. And the reason why I changed all the radicals to powers is because when you apply the quotient rule, within the quotient rule, you're also applying the power rule, and it's much easier to find the derivative when you have a exponent, right? Okay, so let's find f prime of x. Okay, so Darcy, how do I find the derivative of the numerator there? Right? And Darcy, we times that by the bottom. What's the bottom here?
X.
Right. Is that fair there? So Darcy had the derivative of the top times the bottom minus. And then Hudson, what's the derivative of the bottom now?
The derivative of the bottom is
Yeah.
1 over 2 to the x.
Yeah, I'll just write this for now. And then we times that by the top, which is x to the 1/2 plus 3. Is that okay there? Derivative of the bottom times the top? And then what's the bottom going to be?
1/2 plus 1 squared.
Yeah, all squared, perfect. Okay, I need everyone to kind of like maybe pay attention to this next part because there's different ways to do it. And we need to evaluate f prime of what?
1.
1. Okay, I want everyone to just kind of one of the hard things about calculus is that when you simplify steps, it's really like your comfort level with seeing calculations and finding easy ways to do the calculations. And if you can see them quickly, then the rest of the problem just falls nicely into place. If you've forgotten something, then sometimes it's a little bit harder to kind of do questions a little bit more effectively and confidently. And I would say there's in calculus, you just can't follow a step of rules for like memorize a bunch of steps to apply to every single question. Every single question has a very unique kind of way of simplifying it. And I find that that's something that's actually causing some students a little bit of frustration when I see some of the assessments here. Those x's, which I've highlighted in yellow, those x's will change to what value next?
1
1. Now, 1 to the power of anything
is 1.
is always going to be
1.
1. If you know that fact, you can do some of the mental calculations in your head. Does that make sense?
Yeah.
So 1 to the power of anything is always going to be 1.
Yeah.
Okay, so if you know that, 1 to the power of negative 1/2 is,
1.
right, so 1 times 1/2 is 1/2. What's this going to be?
1.
1 plus 1 is 2. This will be what? A half? Yeah, this will be a 1, right?
Yeah.
Times 1/2 is 1/2?
Yeah.
What will this be?
Plus
4,
3.
right? Yeah, 1 plus 3 is 4.
Yeah.
Right, so if you know that 1 to the power of anything is 1, then you can do some of the calculations in your head a little bit faster here. So let me just do each bracket separately here. So we agree that the first bracket is going to be 1/2. What's the second bracket going to be?
2.
2. And right away, 1/2 times 2, we know that's going to be 1, right?
Yeah.
But as you can see, if you know, so this will be what, 1/2 again? And the next one will be what?
4.
4. So right away, I know the numerator is going to be something really nice, right?
Yes.
And then the bottom is going to be what?
1 plus 1 to the power 2.
So 1 plus 1 is 2. So 2 squared is 4?
Yeah.
Right, and then we'll simplify next. So the top's going to be what? 1 minus
2 over 4.
negative 1 over 4, right?
Yes.
Right, so for sure, some of these mental math calculations, it's a bit tough sometimes because I do think some students have done a lot of the abstract calculations and then they forget some of the numerical calculations that are a little bit more common anywhere from like grade 6 to 10, and we just got to get familiar with that kind of math again, right?
And then if you want to make it normal, would you make the slope 4?
Yeah, so let's just do both answers here. So class, over here, let's just write down both answers. The tangent line is what?
Negative 1 over
Y minus
Yeah, so y minus 2 equals to negative 1 over 4,
Yeah.
bracket x minus 1, right? That's the tangent line. And the normal line is just one extra step.
y minus 2 equals 4.
Yeah, y minus 2 equals to 4, bracket x minus 1. So you just take the slope and you take the opposite reciprocal, right? You flip it and make it positive, or you flip it and make it negative, right? So this is negative, the normal line should be positive. And I encourage you to graph this on your graphing calculator. You'll definitely see that perpendicular relationship if you zoom in properly. So is that fair? It's 98% the same thing as the tangent line question,
Yes.
right? So it's very similar to the math 10 question where find the slope of the line so the two equations are perpendicular, parallel. It's really that concept, right? So if you need the tangent line, I have no doubt you can go from there to there within one step. So flip it and then reverse the sign. Great. Now, the questions I like a little bit more for derivatives aren't these ones where we give you the function. It's the ones where we give you the made-up functions like f of x and g of x, because those derivatives are very easy, right? It's just prime something, right?
Yeah.
Let me know if you're ready for me to move on to the last example on the quotient rule here. Everyone's ready?
Yeah.
Okay. Rainer, are you taking a picture? Okay, you know what? It's too late. You didn't get the peace sign. Now the picture's worth nothing. Okay. Well, here's the next question here, and let me just kind of highlight the very end here because that's the function. This is what we need to find. And just like some of the previous questions, let me highlight this in green. You know, all the calc teachers across BC always like these kind of questions, the made-up functions. We're going to definitely start over here. So the green stuff just comes later in the problem, but this is where you start. You start with the function that's given to you, and we want to find f prime of 2. So we take the derivative, and then we plug in that green information. Is that correct?
Yes.
Right. So this derivative might be a little bit easier because we're given these made-up functions, and I'll write down f prime of x over here. Okay. So so Leo, what's the derivative of the top, g of x? Right, so Leo just said g prime of x, right? Notice that that's why I like these problems, because the derivative is very easy. And then you times it by the bottom here. So Leo, what's the bottom? H of x. And then the quotient rule says minus, right? And then Leo, what's the derivative of the bottom? Right, h prime of x. And we times that by g of x. Right, and then the bottom is everything over the bottom all squared, right? So h of x. Now put these square brackets around that, and we square it. So there you go. There's the derivative, and this formula, this expression looks very similar to what you would see on your formula sheet. And then we don't simplify, right?
No.
No, right? We change all the x's to 2, and then we plug in stuff, which is the next best thing to do. So f prime of 2. So what we're going to do here is anytime you see an x, and I will go ahead and I will definitely write this out. I'll write g prime of 2 times h of 2 minus h prime of 2.
Oh, Mr. Yu.
Yeah.
On a test, do we have to write this out, or do we just?
Because you don't have to if you know what you're doing. I'm just going to do this because I just want to make sure. I know this is extra steps, but I just want to be careful. But once you get confidence with this, Hudson, then you can definitely skip some steps if you want. I think what Hudson wants to do is he wants to jump into the substitution method, right? So Hudson, what's g prime of 2?
G prime of 2 is 1.
Yeah. So 1 times h of 2, and what's h of 2?
3 minus 5 times negative 1.
Yep, and the bottom is going to be what?
9, so 3 times 2.
Yeah, so Hudson, if you want to jump to the number step right away, like if you want to skip this and just go from here to here, that's totally fine. I just want to show that substitution step just for completeness. And then, yeah, we get down to this. It'll be what? 3 plus what? 3 plus 5?
5 over 9. Just 8
So,
over 9.
8 over 9, perfect, yeah. Okay, what I want you to do now is I just want you to take 2 minutes to gather your thoughts, bring your formula sheet, and guess what we're going to do the next 2 minutes? A speed drill on what? The quotient rule, because you have to know these rules like that. If you want to use your formula sheet, you can.
What do we do?
In fact, you can formula sheet right here. The quotient rule is right there. Now, class, when we do the speed drill, in this speed drill, you don't need to simplify anything. I just want you to kind of write like this and then leave it alone, right?
Oh, now
You know what? Last class, someone was trying to be a hero. You got it wrong, Hudson.
Yeah.
You're not supposed to go to here, buddy. You're gonna leave the room.
I would just, if you have to find a derivative, just write one line. Don't go back and simplify, right? I'm more trying to get you that repetition so that you can recall the rule. Yeah.
What's 2 say true G?
What's what?
Sean.
What's the derivative of
What are you doing?
2 g of x. Yeah, let me answer that question because a lot of students probably get worried about that. So class, I feel like Leo's asking this. What's the root of 2g of x, right? Okay, let me ask you another question. Okay, so what's the derivative of 2x? Okay, so basically what you're doing is that the constant remains, right?
Yes.
The idea is the constant remains, and what's the derivative of x? 1, right? It's the same idea over here. The constant just remains, and what's the derivative of g of x? Is that fair? So when you see a constant, just leave the constant out in the front, and then take the derivative of the function. Is that okay? Yeah.
What if there is no, like, what if the derivative is zero? Like, what if there's no?
You won't get that case. I mean, it'd be undefined in theory, right? But generally for derivatives, you won't get an undefined situation like that. Now, class, does everyone have their formula sheet in front of them?
Yeah.
Okay, so you got your formula sheet in front of you, you can. But now it's time to execute.
Okay.
I have a quick question.
Okay, sorry.
When I'm writing it out, I write like I just like put like g prime of x here. And then
That's
x
fine. It's like 3 times 2 is the same.
Yeah, it's fine, right? Okay, good.
Alright, here we go. Here we go. We'll be here with the parentheses. Write it once. We'll go back and simplify. We hate these sweet girls. There's so much pressure on them.
Like
My turn. Good luck with your smile. You know what, Jeremy? Your parents love you too.
Wait, we just have to set it up.
Did someone miss it? Right, so just write down f prime of x to start, and then just apply the derivative rule, right? This will also help you review all the other derivative rules that we've done so far, right?
So we just have to do this, that's it? And then over the, but that's it?
Yeah, don't be a hero, don't simplify it.
You can solve it?
No, that's it. That's it. That's all we're doing. That's it. One-liners.
It's really inspirational.
Sorry? Yeah.
Can you check everyone's answers? The
Yeah,
first
well,
one.
the first
No, like the first one.
This to you?
Yeah, that's it. They looked at that. Move on.
This to you? Yeah, I have a, I don't know if I have.
Oh, you didn't have one? Okay, sorry. Jack, I can't believe you're late for the speed drill.
Yeah, I'm so fast.
This class is all about the speed drills now. So we're at the lunch table. Right, the speed drill. No, don't simplify it. No, I was did that. You got it wrong.
Like, what about like that?
Like 5
Just
minus.
leave it alone. Yeah, leave it alone.
Okay.
Leave it alone like that.
No, is that okay though? Like, I'm not multiplying.
Yeah, leave it like that. Yeah, brackets. As soon as we kids start to be heroes, that's when things get ugly.
I should be your hero, Mr. New.
Right, so the purpose of this drill is just get familiar with the quotient rule. Even at UBC, they tell kids not to simplify things. Yeah, that's it. That's exactly that. drink coffee here today. Yes. Leo, are you done? All right. For sure you can. Check it over. Okay, check over there. I think Kevin would do well on these.
Pardon?
I think Kevin would do well on these.
Kevin?
Yeah.
Yeah.
Wait, I need to do
Why not? Kevin's
That's Kevin.
your classmate.
Oh, what's up, Kevin? Nice to meet you.
Oh, dumb mistake.
I haven't been formally introduced to
Dude, he didn't even know how to
Do you want to
spell
partner with him on tomorrow's group activity?
He
Oh,
spelled
yeah,
it
he's
L-U-C-K-A.
fine.
Group
I was like,
Absolutely
dude,
tomorrow. We have one.
He was so indecisive. He was quick.
It's L-U-C-A.
Yeah, why'd you pick both letters?
Because I haven't spelled your name in a while.
At least pick one. It's a 50-50
How do you
chance.
spell my last name?
Yeah, like that,
K-I-R Kirstia. So
yeah. Almost anticipated a million
is it like K-I-R-S-T-I-U-K?
Yeah.
Yeah. So easy. I'm pretty sure I could spell like everyone's name.
Shut up, mine.
Hers like Shaq Boz.
Wait, I think the zeros go on right with you.
That's right.
I think the zeros go on. Look up.
And the power zeros.
Rest of Farias, that's the easiest one. R-E-C-A. J-A-F-I.
Minus one.
Good.
Nine.
A-L-I-A-X. Wait, A-L-I-A-K-B-A-R-I.
It's not that bad.
Yeah.
It's like right how I can do this. But Kuyo's like F-A-P.
F-U-K-E-Y-O.
I was just about to say that.
Fuck you, you know it's not that hard.
F-U-K-E-Y-O.
Yeah.
No. No. Maybe though. Like oh my dad does that shit.
Oh my God, this is what I got.
Victor.
It's like, you know, it's their specific word.
Yeah.
You might be on passes after class.
First, you should do like foot as in foot with an E.
Z as
Shotty,
in
shotty. You want to pass back,
X as in
xylophone.
They're all as in right.
Pass by right across the ball.
Is no A is what? Wait, Darcy. You
No,
said
that's
they all
so funny when they use like
corresponding.
overcomplicated like words. They're like A as in
I know
alopecia.
B is ball.
What?
I feel like B is ball.
Yeah,
B is
alopecia.
Victor.
Please, it's something E as an elephant.
E. Oh, you said
That was
So-
meta.
You got the first
Some
one you
people just
saw.
like use really complicated words.
He as in yo como se llama.
No, like she doesn't.
Oh, I got an eight.
Yeah.
That's you. That's you.
I mean, over
What is this for?
I think that's the formative one.
I actually have a question.
That's the formative, the other
Was
formative.
that the one that Hudson messed up, bro?
Yeah, exactly.
I don't know.
Oh, you're welcome. It's the one up.
All right, class, has everyone handed in their speed drill?
No, one second, I'm just checking it over.
You're welcome.
C as in touch. B as in-
Okay, straight. Whoa.
Whoa.
I don't know how I did that. Oh well.
Apparently mine says just don't have numbers.
Actually,
Why'd you
yeah.
underline
And
it?
just put it on your
Seriously, I
desk.
never put any numbers on my
Yuri,
stuff,
you.
like ever.
Sorry? Yeah. I think one of them was informative, so I just
Mr. Yoon, for the underlined ones, is it just like you have to, like the way that you write it?
no, it's just like I go through all the
Is this one
characters
the formula?
for the numbers. And
Yeah, isn't this one?
one of them is informative,
Please
one's
make it
one's
separate.
remarks.
I haven't gone to 7 more yet.
Are you supposed to get 2 right now?
Mine's underlined. Why is mine
Oh
underlined?
yeah, why are they underlined?
Is it just like, it's like the way you write it?
It's just right.
What the heck does that have?
Underline means nothing.
I guess I'm just.
Wow.
Oh wow, how saucy.
Did Sam write this one
No
too?
chance.
Okay, thank you.
I don't accept.
Okay, what's going on?
I don't accept.
What?
I don't accept.
You try to be a hero, this is what happens.
No, I don't accept.
Alright, we'll talk about later, alright? Sit down, we'll
Did
talk about
Sam
it.
write this one too?
What?
For living situation is slightly less than ideal. No, she's a triple. So 3 people all in one room.
Did
So
Sam
that's
write
no
this
fun.
one?
I
Oh,
don't
I
know.
thought it was a 3
I
times.
just
Oh,
had
for university?
Triple size.
That's
Nope.
so
It's
apparently
apparently when they walk in there. Yeah, it's like 3
Oh
girls.
my god.
Sam, do you want to take a screenshot of this? This is yours. Or do you want me to send it to you over text?
Wait, what is that?
But she knows her mark, it's on the
Does
it's
she?
online,
Yeah,
right?
and so they bring
Okay,
guys.
here's your thing. You got it?
Okay, thanks.
Uh,
Wait, Mr. Yoon,
but like,
hello?
Hi.
Do I ask him, do I have to do the product and quotient one?
I'll ask.
and then 3 desks like
Mr. Yoon,
directly
does
across.
Sam have to do the
So
product
it's like
and quotient?
desks.
Yeah, when she comes back.
Yeah, when you come back, because it's marked as,
Okay,
I got 2 minutes or something.
it's not that bad. It's like only one page, 1 or 2.
okay.
Okay. What do you want me to do with this?
Can you keep it?
Yeah, we'll keep it.
Sam, are you okay?
Yeah, I'm okay. I'm just like kind of sick, but I'm
You know
getting
what?
better.
Hudson's not happy right now. He's
I
very.
think, okay, can I write the investigation tomorrow morning?
Are you coming back tomorrow?
I think so.
I think you might have to write it at lunch because we have kindy buddies at Flex.
No, in the morning.
Oh, Mr. Yoon, can she write it in the morning?
Yeah, we'll figure it. You know what? I would say a flex or lunch period works better for me tomorrow,
Okay,
or after school.
okay. Because I have, okay,
Okay, hey, you know we have another speed run today, so don't worry. We'll have another
okay.
Class. This person get a class. Can everyone please go to the additional problems in your note package? I'm going to do one of them at a time. Every time we learn a new concept, I just want to see if we can apply to solve a problem. I would definitely say that the derivative is like a technical skill. Another part that's good is your ability to apply it to solve other problems here. So I don't know where this is in your note package. You might have to flip through your pages a little bit until you get there.
It's page 24.
Page 24?
Yeah.
So now that we have some technical skills under our belt now, let's see if we can do some application problems. And some of the application problems aren't too bad. And as you can see on this one, there's 2 parallel lines, very similar to maybe some ideas from Map 10. This is something I grabbed from your workbook here, and I do think this is a good one to kind of practice here. We want to find what points does this quadratic function here. So the quadratic function is this thing right here in red. I don't think this came out very well. And it's going to be parallel to this line y equals to 2x minus 3, which is over here. So there it is. There's a red line and a blue line. And somewhere on that red parabola, there's going to be a point such that that point is parallel to this line, right? If the point's over here, is that parallel to the blue line?
No.
No, right? Even over there, is this point parallel to the blue line? No, I mean, the point's probably going to be somewhere on this side of the graph, right?
Yeah.
So the graph tries to help you by kind of pinpointing a approximation like around there, and they draw this dotted line, which appears to be parallel to the blue line. So our goal is we need to find that green dot, right? What's the coordinates of that green dot? Because that green dot will be parallel to that blue line. Does that make sense? So that green dot is somewhere on the parabola, and that green dot is going to be parallel to this linear line over here, and our goal is to find that green dot. Now, because this is calculus, obviously this has to do with derivatives, because what's the slope of that blue line?
2.
Yeah, so this slope, the slope of the blue line equals to 2, right? And just remember y equals mx plus b. Or what's the derivative of 2x minus 3? 2, right? All right, so we know the slope. I don't know why I put down m there, sorry. The slope equals to 2 here, right? Okay, so the slope of that blue line is 2. And how can we apply some ideas to this problem to find that green point?
Can you like take the derivative of that and make it equal to that one?
Kind of, yeah, right? So I'm hearing language like make this equal to that, but what should we make equal to what? So I heard the derivative of
1/2.
the derivative of that red thing, which is
Yeah.
1/2 x squared plus x.
Yeah.
Derivative of red equals to what? Right, so let's write this down. Y equals to 1/2 x squared plus x. So what's the derivative of this?
2x.
X plus 1.
Yeah, x plus 1, right? So
Oh,
1/2
sorry.
1/2 times 2 is x, right? And then we make y prime equal to what?
Would it be the
To 2.
Yeah, because the slope has to be 2 to be parallel, right? So that right there, when you're making y prime equals to 2, that's actually the conceptual part of this question. The rest is now just technical skills now. And what is x equal to?
Oh wait.
Just 1, right?
Sorry.
Now if x is 1, what's y? Right, so what's f of 1? F of 1 would equal to 1/2 bracket 1 squared plus 1. And what's that equal to, class?
That's 1/2 plus 1, so 3/.
And it's funny, so the point's going to be 1 comma 3/2. And if you actually look at your diagram, that point does look roughly like 1/3/2, right?
Yeah.
This right here, that's the key part right there. That's the key. Letting 2 equal to x plus 1, that's the actual conceptual part of this question. Yeah, Nathaniel.
I can't help but notice that the x-intercept on the line that's parallel is also at 3/2. Is that just a coincidence?
That's
or-
just coincidence, yeah.
What type of question?
In
would
fact,
this-
I could give you another line way out here, Nathaniel.
Yeah.
Actually,
So, yeah, totally, okay.
Yeah, it was coincidence for this one, yeah.
What type of question would it be? Would it be like a 4, 5?
I would say it's kind of like a 4, yeah.
Yeah.
It's one step lower than a 5.
And that's not that hard, but also requires a little bit.
It requires a little bit of thinking, yeah. In fact, once you do more derivative questions, something like this will be a little bit easier, right? Setting a value to the derivative expression. So, good. Okay, so class, can we go back to the notes, the chain rule now? I think after the quotient rule was the chain rule. Lesson number 6 here. I kind of just switched gears here because we did the quotient rule, then a speed drill, then we did an additional thinking problem. Now I want to go back to some more rules here. Out of all the rules, I find that the chain rule is definitely the hardest, and even on my test, the level 7-8 question I have for the chain rule question, it's a bit tricky and does require some thought. But we're going to work with some of the basic rules first. So one of the final rules, the second to last rule that you need to know is something called the chain rule. And every single time I talk to my past grads and when they're covering this at university, the prof always goes over some very theory-based composite functions to explain this rule, and I'm just like, well, that would probably confuse a lot of the high school kids, so I just go right into it. But we should always start with something that we do know, like f of x equals to 2x plus 3 to the power of 2. We've done questions like this already. Can everyone just highlight this 2x to the power 2x plus 3 to the power 2? And if we had to find the derivative based on like our current knowledge, maybe you would boil this out and you would get 2x plus 3 times 2x plus 3. And that's going to be what? 4x squared? Plus, is that 12x? Plus 9? So if you were in Mr. Ricard's class, maybe the square, double square technique will work really well. So once you do this square, double square, or FOIL it out, now you can take the derivative, which is f prime of x, and go ahead. How do I find the derivative of that?
8x.
8x plus 12, right? Perfect. Now, what was the power on this question from the start?
2.
It was 2, right? If that power was a 99, you can't FOIL this anymore, right? It just takes way too long. So a way to deal with that particular problem is by learning the chain rule, right? So once again, if this 2 became a 99, FOILing just doesn't work because it just takes too long. So let me show you the chain rule. And the chain rule works whenever you have like a power and like an inside function. Does that make sense? So let me kind of talk about the chain rule first. It works really well when you have an inside and then you have this outside power. All right, so the chain rule works really well when you have an inside expression raised to some kind of power. So right now, 2x plus 3, that's a binomial, right? If you have a trinomial, binomial, all in brackets raised to a power, then that's a good indicator that you might want to use the chain rule. All right, so this is how you do the chain rule. Can someone maybe read out what this rule says right there? That's also in your formula sheet, but what do? The power comes in front, like soccer kicks it.
Yeah.
So it's kind of like the power rule, and then what's the other part? Right, so this part right here, n minus 1 and n, that's the power rule, right? What does this mean? You take the derivative of the inside, right? Okay, so I'm not sure if students saw that, but let me put this in red here. This right here is the inside, right? You're taking the derivative of the inside. Okay. So when you're looking at this notation, it looks kind of weird, but if I do it with a simple example like this, it's going to make a little bit more sense. So let me start off by saying f prime of x over here, f prime of x. Okay. Go super slow here. What do you notice about the power here? This power goes in front, right?
Yeah.
So my power here is a 2, so I soccer kick that to the front, right?
2.
Yeah, so we'll soccer kick that to the front, so 2 times.
2x plus 3.
And then I'll put a 1 up there in red. So does everyone see that the first part is exactly like the power rule? The exponent comes to the front, and you soccer kick the power to the front, and then subtract the power by 1. Now, what's the inside function?
2x plus 3.
Right, so what's the derivative of 2x plus 3?
2.
Right, so you multiply it by that 2. And that right there is the whole n times f of x to the power of n minus 1 times f prime of x. Now, this is correct. Now, class, does everyone see this 2 and that 2?
Yeah.
What's 2 times 2?
4.
4. So this is really 4. And you don't need to simplify this, but I'll do it anyways. And what happens if you distribute this?
8x plus 12. Which is the same as 4.
Right. Does that give us the same answer as FOILing it out and taking the derivative independently? Yeah.
If there's like 10 to the power, if it's like to the power of 10, then wouldn't minus it, just to the power of 9, and you have to do it again, power of 8. Yeah.
Would you just have to do it once?
Okay, so
Wouldn't that still be
Hudson's
hard to
hold on,
find?
hold on, kids. Let's calm down. Let's do this. 2x plus 3, Hudson, right? So Hudson is kind of asking this question here. Let's just put 100 here just to be satisfied here. Does everyone see that?
Yeah.
This is like why we need the chain rule, right? So if I have to take the derivative, the first step is you soccer kick the 100 in front. Then this becomes 2x plus 3 to the power of what?
99.
99. Now what's the inside function? Right, so what's the root of 2x plus 3? None. That's it.
Oh, you don't have to solve it?
No. Well, what's 2 times 100?
200.
Sure, if you want to go one step further and be a hero, you can. Well, that's it. You don't do any FOIL. That's it. You stop right there.
But if you wanted to, you could.
No. If you want to do something else, you're making up some other weird rule that
So you
doesn't make sense.
can't keep doing the
No.
same rule over and over again.
No. That's it. You're done.
What do you mean
I
you
don't-
can do it over?
I think he's thinking of it like a chain, like you keep on
Oh!
doing it continuously.
So Hudson, the thing with chain rule is you just stop once you take the derivative of the inside function.
Name chain rule.
Yeah.
The point of the chain rule is only to find like the derivative. You don't because if you input a name for x, it would still be confirming.
Sorry, I didn't.
Like, unless you have calculator, you couldn't derivative to find any. You couldn't use that to find it. Like that's the last thing you do.
I start from the beginning.
Okay, so like,
Okay.
now I'm. so like that's the derivative.
This right here is derivative. Yes.
Yeah. The 8x is 12.
Yes.
So you only use the chain rule to find the derivative. You can't like use the derivative from the chain.
But you can plug in something.
You know what? Think of the chain rule as a name of another rule. There's a power rule, product rule, quotient rule, then chain rule.
Yeah.
Chain rule has to do with composite functions. And a composite function when you have like a function inside of another function. Like the main function here is really x to the power 2, and then the inside got replaced with 2x plus 3. That's what a composite function is.
Yeah. There you go.
So, like something like this, 2x minus root x to the power 2, right? Notice that it's not a fraction, it's not a product. I mean, you could FOIL this, right?
Yeah.
But notice that you have like an inside function raised to an outside power. When you have something like that, that's a good indicator for the chain rule. If I have to be a little bit more precise, Darcy, now you don't need to write this down here, right? But do you see this part right here, y equals x squared and y equals to, notice that I'm really combining these two functions. I'm taking this and I'm plugging in there. That's called a composite function. And when you have a composite function, that's where we want to use the chain rule. So you know that the f of g of x, that kind of stuff in pre-calc 12, those are the functions where the chain rule works.
And for these ones, you don't have to simplify at all.
Mm-hmm. Now, I would say this is your inside. And that's your outside power, right? Now, before you start taking any derivatives, I do recommend that you do this first. Is that fair how we changed the radical to a power?
Yep.
All right, so we haven't applied the chain rule yet. We're just changing that radical to a power, right? And go ahead. How do I apply the chain rule now when we have a question like this?
Y prime equals 2 times 2x minus
Okay, so 2 times.
Even solve. And what's the power of 1?
Is that part okay there?
Yeah.
Okay, and then what's the root of the inside?
times 2 minus 1 half x to the negative.
Yeah. That's it, you stop there. So this part right here, class, that's the derivative right there, right? It's interesting because most students don't realize this, but I need to write an idea in front of everyone here. Does everyone see this? Y equals x to the power 4?
Yep.
You may not realize this, but we've been using the chain rule the whole time. We just haven't really noticed it. How do I take the derivative of this?
Oh.
It's like 4x cubed.
And
what's the derivative of x? What's the derivative of x? Yeah, the derivative of x is just 1, right?
Just a continuation of what we
that's
did.
crazy.
We've been doing the chain rule the whole time actually. We just haven't really defined it. But if you think about x to the power 4, 4x cubed, and what's the derivative of the inside? Well, the derivative of x is just 1, right? Yeah, so we've been doing the chain rule the whole time. But now it's a little bit more clear when we have a binomial in our brackets, right? When we have an x, that's like a monomial. You don't really see that much, but once you have a binomial or a trinomial being raised to the power, then we can see the chain rule a little bit more clearly, right?
Are we going to do like
Yeah. Well, hold on. We need to get there, right? It's the made up functions that are hard. The made up functions are hard. If I give you like something to the power, it's not too bad. But once I give you something different, then it's
really hard. So hard.
Okay, so class, let's do a few more of the simple chain rules. And then Darcy's asking, what do the harder chain rules look like? I'll show you in a bit, right? Let's go ahead and figure out this. What's f prime of x? These ones we should be able to do super fast now.
10
So
times
10 bracket what? X to the 4?
plus 6x3 plus 2x plus 3 to the power of 9.
Yep.
And then that'll be times 4x3 plus 18x to the power of 2 plus 2.
Right. So Darcy, stuff like this is still like level 2, right? I would say for the next one here, I see a radical sign there. So what, this one's a little bit harder because you need to recognize and write this as 2x plus 3 to the what power?
1/2.
1/2. So these ones are a little bit better because you have to recognize that there is a power, right?
Yeah.
And then let's go with y prime. So the res, how do I find the derivative of this?
The derivative. Oh, it's 1/2 times 2x plus 3 times 2
What's the what power?
to the power of negative
Yep. And then times by what?
times 2.
Right. Now, class, I want to stop you on this one here. Although this is absolutely correct, this is totally correct. And I recommend, like, when you're learning this for the first time, like, don't be the hero and leave your answer like that. Later on, what do you notice about this and this? They cancel, right? So later on, we have to be also good at this method where we have to change this back to this. But for now, this is okay. All right? That stuff is okay, but you should also be good at later on, especially in chapter 5, of changing that expression back to a radical, right? So those are some things that I do find are annoying for calculus students, that they hate doing that. But once we get to chapter 5, then we've got to be good at it. Okay, so I would still say that this is definitely under level 4 in my opinion. And then Darcy, let's get into some other questions here, right? These are starting to become close. These are starting to become a little bit closer to level 5, because the chain rule now becomes these combo questions now, right? That's where I think there's a little bit more work to do. So if there's this one function here, and there's this function there, this is really like a product, right? This is the product rule here. But within the product rule, you have to use the chain rule, right? So let me walk you through the product rule here. So Darcy, what's the derivative of the yellow function? Right, 12x to the 3. And then we multiply that by the second term, which is 4x minus 1 to the power of 3, right? And then when you're dealing with a product rule, is it a plus or a minus sign?
Plus.
Yeah, it's a plus, right? And then, Darcy, we got to take the derivative of blue now, right? What's the derivative of blue? Yeah. No. 3.
3 on 4.
Right. Inside.
Oh.
Yeah. And that's the derivative of the blue part, right?
Oh my gosh, are you okay? Woo!
Did the chair break or?
Did you find the name?
All right, and we times this by 3x to the 4.
That's so loud.
So Darcy, is that okay there? So once I start combining, yeah, Leo, question? Yeah. Product rule, right? Derivative of the first times the second plus derivative of the second times the first, right? Product rule, product rule. Yeah.
So where's that red 4 coming from?
Derivative.
That's a part of the.
What's the derivative inside here? Yeah. So do you see that 4x minus 1?
Yeah.
What's the derivative of 4x minus 1? Right. So Darcy, where the chain rule gets a little bit annoying now is when we combine it with a product rule or a quotient rule, right? And then you once you're combining multiple derivative rules, that's where it gets a bit confusing, right?
So this is a 70?
No, this is still like,
Well, I
I'll
feel
I'll be
like,
honest, I still think this one's level 4. Once you
feel
get
like
good at
since-
this,
This is
once
7,
you get
man.
once you get good at this, then you'll like say, oh, I know how to do that. It's easier, right? But right now we're still learning this, right?
That's so hard, I can't do
Before I
that.
go, what's the very bottom question? What's that?
D.
Like that example.
would
D?
that be the equivalent
Below
of
D.
saying like,
Delete, I
This
think
one?
D is just quotient rule and chain rule, right?
Yeah.
Yeah.
Do you want me to do this one right here?
Yeah.
Okay.
Is that also just quotient rule?
Sorry, class. Is it okay if I quickly go to this one here?
Yeah.
I'm gonna skip D. Is it okay if I go to the letter? This example right here.
Can you just make the top and the bottom separate?
Well, this is what we'll do here. First, I'll just really quickly here. You gotta write x to the power of 1/2. Is that fair? What we're doing with the radicals? Right. So no about derivatives yet. Okay, so this is going to be a chain rule first, and then a quotient rule, I believe, right? Okay, so y prime. So Darcy, what do I do with this 3 right here? Right, with soccer kick it to the front, and then what stays the same? Right, which is x to the 1/2 over x to the 1/2 plus 1. And what's my power here, Darcy? Right, so there we go. That's the easy part, right? And now the chain rule says that we take the derivative of the inside. The inside is all of this. Does everyone see that? We have to take the derivative of that. So we're going to get something really ugly over here, right? Does that kind of make sense how the chain rule is really now inside, a quotient rule is inside the chain rule now? Okay, so what's the derivative of the top, class?
1/2 x to the negative 1/2,
Right?
and then times x to the 1/2
And then times the bottom, which is x to the 1/2 plus 1?
Yeah.
And is it plus or minus?
minus.
Minus, right?
And then same thing for 1/2 x to the negative 1/2.
Yep.
Then it would be x 1/2 plus 5.
Yes.
And that'll be all over x to the 1/2 plus 1 squared.
Right, so Darcy, you see how we did that one now?
Yeah.
So this is why I think chain rule is annoying, because we really hide it within other functions.
So for like these types of questions, you would always do the chain rule first and not the.
This is where it's really hard to answer that. It really, you have to look at the question, see what comes first. Because if we do the previous example, we do the quotient rule first, but within the quotient rule, we do the chain rule, right? This one, we did the chain rule first, and then
Like
the quotient rule, right?
Like let's say it's not like individually like on the like numerator and the denominator, but it's like on the entire thing.
Yeah.
Would
Then-
that just
yeah.
be the chain rule? And
Yeah.
then if it's like on the numerator bracket and then denominator bracket, then you would do the
Quotient rule, yeah.
first. Okay.
So class, I'll be honest with you, with the chain rule, I don't expect like the majority of the class to be super good at this. I feel like this is probably the hardest rule to master within like a short period of time. And you really, even if you mastered it, if I give you like a really hard level 7, 8, it would still be tough. And this just comes up with a little bit of experience, to be in all honesty. So don't worry, we'll work on this until we get good at it.
Do you mind going over to
Yeah, I'll go over D here. Does everyone see the difference between D and this? Does everyone see the difference between D and the one that we just did? How the question's set up?
Yeah.
Right, so D's got 2 powers, right? One on the top, one on the bottom.
If it gave you like, say, like the brackets the cube on the outside, but in the brackets, there's like a fraction and another like function.
And that's when it gets harder, and then we'll get to those
Can you
ones.
just do like can you just throw it over one and then do like the smiley face thing? Are you allowed to do that? And you can just,
You can, as long as you're not taking the derivative.
okay, so you can
You
like
get
make
the all
it nicer
algebra first, yeah. You have to clean it up first before you apply your derivative rules. So class, this one's a little bit nice because this is really the quotient rule to kind of start, right? Let me kind of highlight the top and the bottom here. Yeah, we just did the quotient rule here, and the only thing that's really different compared to the speed run is that there's powers of 2, right? If the powers of 2 weren't there, then everyone could do this quite easily, I think, right? Okay, let's see if we can write out a very long expression for this one as well. Okay, so Jeremy, what do you think the derivative of the top is? Yeah, the yellow expression. What's the derivative of the top yellow expression? Yeah. Yeah. To the power of 1, right? That's it. That's it. Well, what's the derivative of x plus 1? 1, right? So I'm not sure. Do you want me to put the 1 there just to be safe?
Yeah, I think
Sure.
it's like
Yep. And then what's the derivative? And then we times this by what? The bottom? Right. So the bottom just remains as x cubed minus 2 to the power of 2. So the derivative of the top is 2 bracket x plus 1 all to the power of 1 times 1 times by the bottom. Does the quotient rule have a plus or a minus sign? Minus. Okay, now we need the derivative of the bottom. So Jeremy, what's the derivative of the bottom now? Yep. Yep, to the power of. Yep. Yeah, perfect. Does everyone see how Jeremy got 3x squared there?
Yeah.
That's a chain rule right there, right? He's basically taking the derivative of this guy, right? And then we times this by what now, Jeremy? Right, which is x plus 1 all squared. Yeah. And the nice thing is we don't need to simplify that, and I refuse to simplify this. The nice thing is the bottom is a little bit easier than the chain rule. Is what's on the bottom, Jeremy? Right. Now, if you square the bottom, we really have a 4, right?
Yeah.
So 2 times 2 is 4. So that's great. The bottom is easy to do, but the top, there's a little bit of a mess. But as you can see, that once you put the chain rule in there, there's a little bit more of a thought process, right? So it's easy if I give you something like this. Darcy's like, okay, that's easy. We're the level 7 and 8s. The harder questions are when the chain rule is embedded into another problem, and then you have to really break it down and see what we can do, right? Cool. Before I give you a break, I definitely want to go over a few more trickier problems with chain rule here. So Darcy, do you see these ones here? Now we're starting to get into level 6. This is definitely a level 6 one here. You know what? I'm going to skip this one here because it's going to confuse a lot of kids. Let's do a few more easy ones first.
Can we take a break?
Okay, let's take a break.
Yeah.
Take a break.
Wait, Luca.
Oh Jesus, you scared me. Oh my god.
Hi.
Hi.
Wait, okay. Can you ask Mr. Yoon to come when he has time? Because I have to ask him, because I can't do the investigation because I'm busy at Flex and lunch and after school.
Okay. Yeah.
I can, or can you tell him to come?
Can I do this? Can I take
Let's wait
Mr.
till you
Yoon,
do this.
Sam is calling you.
What do you want, Sam?
Can I do the investigation in the morning? Because
You've been
I have
disqualified
field-
from the investigation, all right?
what?
You've been disqualified from the investigation. If you want to do it again, you have to do the C to G term.
Because I have a field hockey game after school.
No, you
and
don't.
Field hockey things at lunch and
you don't.
buddies at Flex.
Okay, you tell Miss Bruner that calculus is more important than field hockey.
That's not going to go over well.
Yeah,
I mean,
know.
I can try
know.
and do it at lunch.
Okay, do it at lunch. Okay, if you want, I can come here at 8 o'clock. Is that okay?
Or is another teacher here early? You can just give it to them.
I don't know who's gonna be here early tomorrow, but I can be here at 8, and we can do the first part, and then you can do the second part during lunch. Is that fair?
Sure. Yeah.
Okay. Are
Okay.
you gonna be here tomorrow?
Yeah.
But you sound pretty sick.
No, I'm not sick. My voice. I just lost my voice,
Is
but like I'm better.
Miss Bruner threatening you to play field hockey tomorrow? That's why you're coming.
Yeah. Oh, also this video is gonna be shared with the rest of the class. Okay.
Okay.
Miss Bruder. Yeah. I don't know. We'll
Okay, that's
see.
fine. That's fine. Yeah, just come in tomorrow morning at 8, and we'll figure. Hudson, get out of here, man.
Wait, how long does it take to write it?
Sorry.
How long does it take to write it?
I'll be honest with you. It really depends. I mean, some people did it quickly, and others couldn't find the aha moment, so it took a little bit longer. So
Okay.
I don't know. I think like 40 minutes should be good enough, but we'll see.
Okay, I'll come in at 8.
Okay.
Thank you.
We got a bracket there.
Oh, no, I'm gonna do it.
You need to put a bracket there.
Stop bothering me. I'm doing it right now. Patience.
I don't understand what break.
Patience.
Wait,
This makes Sam dizzy.
Watch out, the
Oh wait, I want to see if we got Sam.
Hi Sam, how are you doing?
Hi. I'm good.
Can you like see everything? Is everything making sense?
Yeah, perfect. Perfect.
Perfect.
Okay, this is kind of confusing me.
This video is being videoed for the whole class.
wait.
Yeah, it's for the people who aren't here.
But like, isn't it only you who's not here?
Rosa, what is
What?
He's doing the question.
That was directed past you to Rose.
That's like Sam.
Kiana is Rose.
Stop.
Whoa.
What?
Wait, Kiana,
Yeah.
do you think I should miss social justice? Is it cool they're gonna be back?
Probably, I think.
Okay.
Yeah, I'm like, oh, we still want to with the manifesto and it's due tomorrow. Like, at the
Isn't
end,
it just like a page about something you believe in or something?
I don't know. That's what I'm just gonna write that tonight. Like, random, and then we'll see what happens. I think I'm gonna email her too. Like, I don't understand what this is about. Like, most of the class doesn't. Okay,
Yeah.
he's emailing her too, so you should email her too, so it's like more powerful.
Okay. I think it's fine. I think it's fine.
Okay, I'm putting you back now.
Wait,
Okay.
what are the you bring this through?
I know. It's good.
At the inside.
Sam, can you see it?
No.
Yeah. Yeah.
Here, I want
That's Mr. Yin.
Yeah, I'll be here at 8 o'clock tomorrow.
be
What's
like.
behind
Can I
you?
only retake my first?
Sorry? Sure, why not?
Okay.
Wait, but Ray,
What?
the grade cutoff is today
What's the grade cutoff?
What?
for midterm report cards.
Oh,
You
I
have
know
to
the
put it
exact
into my
same.
grade. Actually, it's just 11, right?
Oh, wait, no, this is
You know what?
the
I'll put it for next class.
This is
Next term.
We better be in the
Mr. Yin.
Emily, you're back.
Yeah.
You know what, Emily? I talked to all the Boza kids, and they say they don't even know you.
At this point,
Yeah, I don't know a lot of them either.
I talked to Oliver. He has no idea who you are.
Oliver?
Yes.
I mean, I guess the last time I ever spoke to him
Oliver
was
Boza.
Wait, Kiana or Luca, can you put it to the left a little bit?
Pardon?
Can you put it to the left a little bit? Okay.
Left? Like that?
Yeah, that's good.
The
Is
size,
that
size,
Yeah.
size. Really knows who you
Okay,
are.
like that. And then you do next
Next
derivative of
That's
this.
most
No, they want it.
So then
You
you
want
go-
hydrating skin mist?
Oh yeah, guys, let's
then you
touch
go
up.
here.
Fantastic
And then
question.
you do
Right?
Yeah.
Sandwich is good or
Like
not.
that. So then you go
I don't know.
say that 1/2 times 2 is 4. I did. Did he do?
Right?
Wait, okay.
Oh my gosh.
Did he do like here to here? Did you distribute it to here?
You did
Just
derivatives.
use
when did
negative
I
one.
come out?
Did you do derivatives?
Oh wait, no.
You want me to know
I
why?
left
Take a
after
sip?
Did
Yeah,
this- So I did like 4 minus and then 1/2. Wait, so then this, the inside of that would be negative 3x squared equals 4x power 1, right? Yeah.
You
So
want
then
us
I
to
would
run
do
it?
negative 1/2 and then 3 minus
But I get one in
x
common.
power.
All right, I'll tell
Do
you
I-
what
am I
it is
supposed to?
before they come right
Is
tomorrow.
that part of it?
Yeah.
You guys know this.
Should I do this right?
Yeah, which one? Oh, geez. Let me see.
Yeah, Russ, you wait until the market cutoff for it.
2x squared.
Mark.
Oh no, Vish, help me with this.
It's the same question.
I know. So like, okay, this is the inside of
Yeah,
this.
yeah.
So it's a derivative. Okay,
So you're just doing the inside. You're not worrying about the 3.
Yeah, so I did this already.
Okay.
Now I need to worry about this one. But where do we distribute this
To the
to the 2x?
No, not
no,
to the
no,
2x.
just to
Just the inside?
Yeah, yeah.
So you have to do this one separately.
Yeah.
What do you mean?
What do you mean?
It's like you have to make it 4x.
Why?
Why?
Why? Why?
Like if then you do the derivative of this and the
But I already distributed this to here. This is part of this one. Is it not? So then this would be like, so then if
You know what?
it's
I gave
focused
you a
on
5 by the
this
way.
one, so it'd be
You're doing this
negative
test. This is
1
really a
half
6, but I'm like, you know what? I
3x
can change
squared
my
minus
mind.
4x.
Just to send a
That's
message.
negative 1 half.
Just to
And the
send a
derivative
message
of
here.
inside is
Just to send a message.
6x minus 4.
And you, did you talk
So
to
it
the
should be like
stage
that.
wait.
Let me do it. Let me do this question.
Okay.
Where's Devin Marker?
Fish, where are you, man? What are you business grade 8?
Dead.
Yeah.
How come you're not in band class with Regan?
I don't do bad.
You don't do band? I didn't realize there's like Hollywood kids taking back.
Sorry, I'm just gonna erase this.
Oh, not me.
One at Westbound
West
Rec.
Bend Youth Band?
What kind of program do they run there? Is it like some kind of bands or wonder or
The
just like
You spelled that wrong.
There's no one
There
level.
was-
There's different levels.
There's some serious kids in that band class. And I was like standing at the top waving to people and they're all like, who's that person? And then just I started putting the peace signs.
Yeah.
It was interesting.
Wait, what?
I'll talk you through it, so I can.
Yeah. I did.
Am I missing something or skipping?
Right, this, right?
No,
This.
no, am I
What?
Back to this.
No. So it would be
There.
Wait! Oh my gosh, no, you're right.
No. Wait, no, but then you would have to.
What, Fish, go home.
Wait, Mr. Yu, wait, I have a question.
Ask Emily Boza. Emily Boza, how do we do this?
What's this now?
Yeah, this derivative. How do you find the
Okay, so
derivative?
you basically just have to do some math.
Yeah, exactly. You do some math, right?
With
Where's
this-
the math?
with
And then you
this-
answer it. Simple. I can do that. I know that. Who's on the call here? Is this Sam again?
What is everyone on the same rate? Why they gotta mark off?
Oh, yeah.
This is
Yup.
inside
Yeah.
that.
It wasn't this was
The second time.
Oh, it's always me. It's always me. I don't know why. I did it. No. Yeah. Minus 4 to the negative 1 over 2.
And then you have to do this. So
I don't know.
Yeah, well, yeah.
Yeah, I think so, yeah.
You might have to like a voice at the same time.
You're supposed to be useful.
Whatever.
You're supposed to help us.
We're gonna do this once everyone's got good grasp of the chain rule. So we'll work on that next time.
Okay, let's go over to minus by 1 half. This, I feel like is correct. And then from here on, you have the derivative of this guy, right? So we have to take this individual piece, that's 4x, minus, and then you have to do that.
Yeah, it is the same. Okay,
So
these
minus
two are
1
the same.
half, yeah.
Mr.
And then to
You.
derivative of this, which is equivalent to that. And then this thing we multiply it by this. Okay.
Because this is the inside of
That's why I was.
Yeah.
We are.
Chain rule.
That is so confusing. Look at the question. That's the answer.
It's a lot of like brain power required.
No, actually, I actually really good grade.
One of those days.
What's your last math class you took?
We yelled at who?
We took calculating.
Calc
You
AB.
want to come back to calculus?
No, Miss.
That's just the questions are horrible. He's like 100 something.
No, I don't like that.
This is the first time like AB kids are coming like Calc 12. It's supposed to be the other way around. Not like.
Yeah, like if
I
I'm
was
strong.
You know what?
You got a
That's why I
5?
get 100% every
I got a 4.
I got a
I got a B. I got a B and I got a 4.
Yeah, she didn't think the year before. Amanda. And then she ended up taking this year again because she wasn't happy with her one.
Wait, Calc AB?
Yeah.
That does make sense.
With Mr. House. Mr. House is the reason.
This is such a hard one.
I started with the mentality, we still have 6
Yeah.
tests. Oh, we still have 5 more tests. And then it just started like decreasing.
No, but then you know.
No, it's just-
Very hard.
Cause like, you know, like some like old like he said he was and like and like I need the grace.
If she didn't understand it when she was asked, so she would have
No,
said
you
John.
You want confirmation from John and the field coach wants.
Wait, Tristan, which you need
Biology. Oh no. And university.
engineering, right?
For science,
You need to
you're lucky I was in this class. I should probably go back.
No,
Alright, Calc 12 students, can we get back to class, please? Calc 12 students, Calc 12 students. Yeah, the res, can you get everyone back to order now? The res. Can you get everyone back to order now?
Everyone to your seats, please.
Please don't yell.
Alright, Calc 12 students, can we go over some more chain rule stuff here?
Oh, use your library voice.
Now, Calc 12 students, I probably need another class to talk about chain rule because one of the harder ones I just don't want to go over today. I feel like we still need to know the fundamentals before we do some hard ones. But if you go back to the top of your notes here, I hope everyone sees this notation right here. This is the other part of the chain rule that we have to deal with for Calc 12, is when I give you just like the imaginary functions, f of x and g of x. And I want to make sure that students are okay with this notation because this notation is a little bit weird. And let me kind of go over some simple examples on the side. You don't need to write this out because I'll repeat it again. But I want to go over some problems like this where I give you f of, I don't know.
Jesus, you skipped the shit. What?
Can you move it?
Yeah, sorry.
If I give you something like this, f of like x squared, and if I ask you to find the derivative, this one's a bit weird because this is now the outside function, and this is now your inside function. How do you take the derivative of the outside function? So the derivative of f is what, f prime?
Yeah.
Now, this all stays the same, right? Because you're just taking the derivative of the outside function, and then you multiply this by the derivative of the what?
Inside.
And what's the derivative of the inside function?
2x.
2x. This one is actually quite weird for students to grasp when I give you just a generic expression like f of x and g of x. I find that this one, we should spend some time on figuring this out instead of doing a very long, complicated chain rule problem. But if I give you regular letters like this, I want to spend a little bit of time going over problems like this. If I give you this now, f of, I don't know, 4x to the 4 plus 2x, what's my outside function again? right? If I take its derivative, it'd be what? F prime of what? Right, notice that we leave this alone, right? We're leaving this alone, and then times what?
63.
Right. So when we have letters, the capital F is now the outside function, and the inside function is whatever's in the brackets, right? So you must take the derivative of the complete outside. It's weird because this whole thing is really the outside, right? So F prime of everything, and then times by the derivative of the inside. That's the idea. The one that I thought is really weird now is this. Okay, if I give you one more, like, I don't know, 4x cubed, 4x squared. This one's easy, right? F prime of 4x squared times what? 8x. Once you've seen enough of those, that looks okay. The one that always throws students off is this one.
Oh, yeah.
We open the brackets like this. This is the one that kind of throws students off because now there's too many things, too many brackets, right? So, but what's the outside function here?
F prime.
Right, so it's still F prime, and we keep everything in the what?
Oh, that's actually not the G of X. Oh, you just do G prime.
Right.
I think it's just the letters that are.
It's the letters in the brackets that throw kids off, right? So when I give you these made-up functions with f of x and g of x, at the beginning, this is where I also find that students have a difficult time doing composite functions because the derivative of a composite function is really intended for the chain rule, and you just have a lot of weird brackets that come up. But when you're given this letter notation like f or g, the outside function is really the stuff on the outside, right? The entire thing. And then you start taking the derivative of the inside, right? So does everyone agree that this g of x is inside of f of x?
Yeah.
So the kind of questions that get super annoying, which what Darcy was asking about, what happens if I have a function inside of g of x, and then g of x is inside of f of x? You see what I mean with that? Then there's multiple chain rules within a chain rule, right? That's where it gets a bit tough. If we stick to these basic ones, we're kind of okay. But we'll do the level 7, 8 ones at a different date because we just need to get better at some of the basic ones, right? And by the way, out of all the derivative rules, the chain rule is the one that causes the most amount of confusion here, right? So let's see if we can differentiate some of this now. Uh-oh, there's some tricky ones here, right?
Yeah.
Okay, I'm gonna pick on Darcy here again. So Darcy, my power is 5, right?
Yeah.
Okay, so if I apply the derivative here, what do we do first? Right, so 5 times f of x. Remember, f of x just stays the same, right? And then the power of 4, right? And what's the inside function now? Yeah. Right, that one's not too bad. The 5 we soccer kick the 5 to the front, change it to a 4, and then we take the derivative of the inside function, right? I want to say that a common mistake was what students do. This is a mistake. A lot of students do this. A lot of students do that. So just have a note there that's not right. When you take the derivative of the outside, you can't touch the inside at all, right? Because the inside is part of the outside. A lot of students do that, but it's actually incorrect.
I think it's easier to just start by identifying the outside and the inside before doing the problem.
And it's hard because there's brackets, right?
Yeah.
All right, Darcy, what's my outside function here now? Yeah. Okay, so let's see if we can do this one, y prime. And what do we do with that to, Darcy? And then leave everything alone, right?
Yeah.
We leave everything alone. We leave everything alone, and then, so notice we take care of the outside exclusively, right? We don't change anything on the inside. And now, Darcy, we have 2 chain rules coming up. What times that by? What's the outside function now? Right, so what's the root of that? Yeah, f prime, and we leave everything alone, right?
Yeah.
We leave this inside alone. And then what do we do? Yeah. And that's why these questions are a bit confusing, because you did 2 chain rules in that question, right? You did that green stuff and then the red stuff at the end, right? And then the power rule at the start, right? So that's where I find the chain rule. That's where it gets confusing when there's a chain rule within the chain rule, right?
If that's the case, though, then shouldn't the A1 also be times?
Which one?
Oh. Is it like A is kind of like technically like times 1? Is it the X inside?
Yeah, the derivative of x is just 1, right?
Yeah.
Yeah. Okay, we've got another tough one here. Another tough one, class. Hudson, do you want to give this one a try? What's the outside function here?
-9.
Right, so there's a 3 here, right?
Yeah.
So y prime would equal to
-9. Square bracket f x squared minus 4x power 2 times f.
okay, so hold on, let's do that part first, all right? I think most students are okay with that rule right there. I would say everything after this is where things kind of get confusing, because I'm looking at this part here in green, and I know this is we did a few of these, but it's coming up inside here, right? So so Hudson was able to change this 3 to a 2 here, right? So I think students are okay with that part, but is now taking the derivative of the inside, which is a bit confusing. And what's the outside on this green part here? F, so it would be f prime. Now remember, we leave this alone, right?
Minus 4.
Minus 4.
Times 2x, yeah? We're not there yet. We're taking the derivative, sorry, Jack, we were taking the derivative of this part right here.
Oh.
That's the derivative of that, right?
Yeah.
And then we say minus what for? So for sure, this is a bit of a tricky one there, right?
And then would you do, would it be 2x times 2?
That's it.
That's it?
That's it.
Oh, no, never mind, sorry.
Now, class, I still feel like we're not good at this yet, so let me just put some rapid fire questions up on the board here. What about, how do I find the derivative of this, class? So y prime would equal to what?
F prime 4x,
4x.
and then multiplied by 4.
Perfect. There's another one then. What's the root of that again?
F prime x.
Notice that when we say f prime, right? This is key. When we say f prime, everything else stays the same, right?
Yeah.
And then we times it by what?
2x plus 1.
Right. Is that fair? When we take the f prime, everything else stays the same. And then you take the derivative of the inside. Okay, what about this? Oh, hold on. And then I put this now here.
Then we do.
Someone new. Noah, how do I do this? 2 in the front, yeah?
And then
Rest stays the same, perfect, right? So the outside function is at power, right? And then we put a 1 here, right? Then we take the derivative of the inside, but there's also rules of that. So f prime, and then everything stays the same, right? And then what?
And then it's the derivative of 3x times 7. 3 twice less 1.
Which is 4, right?
Yeah, pretty much. Just finding the derivative of the inside. So just you continue to look at the inside. So you go from outside to inside.
So yeah, whenever
and
you
then the inside
whenever you write
becomes
down
the
f prime, the bracket's the same, and then you multiply by the inside, right?
So
Let's do another one. Let's do g of, I don't know, 3x squared. Okay, so Nathaniel, what about this one? What's the derivative of this?
Alrighty. So we have g prime.
Yep.
Of 3x squared.
Yep.
And then we're going to multiply that by what we got 6x.
Yeah.
And that's it.
So yeah. Nathaniel, stay with me for a sec. What happens if I do something like this now? What's my derivative now?
All right, so we're gonna, so after we take the 4 out in front, so we're gonna have 4 times g of 3x squared multiplied by g prime of.
We need a 3 here, right?
Oh, you're right.
Yep. Then what?
Multiplied by g prime of that's gonna be 3x squared. Is there still the 3 up there? No.
No.
Not, okay. And then that's going to be 6x.
Yeah, so it takes a little bit of practice to kind of get good at it. And as you can see with this next one here, this one's kind of like getting into the, yeah, this is kind of getting into level 7 there, I think.
Where?
This table one.
Wait. If it's like g of 3x squared, like if the if the square is outside the bracket, would that still be counting as the outside thing?
Yeah, like that.
Yeah.
Yeah.
And then
So what's the root of this? What's the root of this, Reza?
would it be 2 bracket g to the 3x,
Mhm.
and then g prime 3x times 3.
Yeah.
Okay.
Yeah, it's definitely not easy. It takes a little bit of time to get familiar with the notation, right? Does anyone want to give a shot at this one here? This one's another weird one here with the F's and the G's, right? Hold on, we know Jack's ready to do this, I think.
Okay, f prime of g.
Hold on. We have to put down h prime of x first, right?
Oh, yeah.
Yeah. I think you're rushing on to this one here, right?
Yeah.
Okay, so what do you think, Jack?
It's f prime g of negative 2x squared plus 3, and then you multiply by g prime negative 2x squared plus 3, and then multiply that by negative 4x.
That's it. You got it.
And you gotta input the 1.
Yeah, we're gonna put that, but even taking that derivative at this stage is really tough. So Jack, did you feel very confident with that, or did you fluke out here?
I felt pretty good.
Okay, that's correct. I would say if you can take that derivative, then you are getting very close to like a level understanding of the chain rule. I think stuff like this one right here is the toughest, I think. You know what? I'm gonna erase this again. Darcy, do you want to try taking the derivative now?
Yeah.
Okay, give it a try, Darcy.
Okay.
Yeah, that's what I thought. I erased it.
F prime
Yeah.
onto g negative 2x squared 3
Right.
times g prime onto negative 2x squared plus 3.
Right. Notice that you're keeping everything the same. Yeah.
And then multiply that by so negative 4x.
Right. Good, Darcy, you got that.
Can you give us an example where it's like coming from the same class as that one, but
No, we're not gonna go too far. We're gonna stick with this first. No, we're not gonna do that yet. We will later, but I just wanna make sure students can find a derivative of that. If you can find a derivative of that, then you have a pretty good understanding of everything here. Now class, we're gonna find y h of prime of 1. Okay, so we're gonna find h prime of 1, right? Now I do recommend students to write out the next steps here, right? So I know some students want, this one's a bit tough to really do this all in your head here. So I would write out, what do you do with all these x's here?
You could change it to 1.
Right, so what's negative 2 plus 3?
1.
Right, this part right here, isn't that just 1?
Yeah.
And what's inside this green bracket?
Same thing, so it's just 1.
Yep. And times what?
-4.
So make sure you're okay with evaluating all of this, right? This is really equal to 1, right? If you change those x's to a 1, negative 2 plus 3 is 1, right? Negative 2 plus 3 is 1. And then class, if you look at this stuff right here, this stuff in yellow, where do you find that?
On the table.
On the table. Does anyone know where g of 1 is?
-1.
Negative 3?
Is it -3? G of 1 is -1, and G prime of 1 is -1.
So g of 1? G of 1 is what, -1, right?
Yeah.
Is that fair? G of 1 is -1?
Yeah.
So f prime of and what's g prime of 1?
-3.
Yeah, g prime -1 is -3, right? And what's -3 times 4? 12, yeah. And what's f prime of 1? F prime of -1 is
-2.
goes negative 24, right? Now, this stuff is super tough when you're learning this for the first time. I think some of my homework video guys, I go super slow when I explain this. We need more practice with this. I don't expect the entire class to be very good at this right from the get-go. It's a bit of a tough one where your attention to detail has to be very good. So we'll work on this a bit more. I'm going to give everyone a few minutes to kind of look at some of the basic chain rules. Because at 3 o'clock, what do you think's going to happen at 3 o'clock, class? Okay, 3:05.
How hard would it be?
What's class over?
3:30.
We still have another half an hour to go. Okay, we're taking a break. Let's do the speed drill outside, people. What? We do the speed drill outside?
Is the chain rule on here?
Yeah, it is. It's in the FOG stuff.
Yeah. Wait, so
Well, I find it
what's happening?
Yeah, sorry. Hi.
Wait, so are we doing any more notes or no?
There's one thing I'm going to cover, and then we'll call it a day with the notes.
Okay.
Yeah, that's fine. Does everyone have the capacity to do one more thing in the notes? This one will be a little bit easier.
No, wait. Can we just take like a 2-minute break?
Sure. How about 3 o'clock? I go to the last part of the notes. We are. There's one more thing I want to talk about, but I don't think this will take too much time. Class, does everyone still have this handout?
Yeah.
Yeah, if you have that handout, I just want to go over this page really, like question number 2 more than anything. I think question number 2 is going to be a little bit easier for people to absorb than the chain rule. The chain rule, this F and G and all that's a bit weird, so I agree. Let's take a little break here. I know we've been going at it for a little bit of time, so let's just kind of.
Oh, a break right now?
Wait, Luca.
Yeah, we come back at 3 o'clock to do this
Okay,
one.
well, let's do it.
Luca. Hello.
You know, it'd be a level 6.
What?
Because like once you know how to do it, you know how to do it. After all, that's your one, so you level 7.
Luca.
It's kind of like
Yeah.
unfamiliar, right?
Hi. Wait, what handout is it?
It's this
She
one.
wasn't here for that.
Oh.
Oh.
So basically,
Oh.
you are going to. It's the quotient rule, right? So I'm gonna write down the quotient.
Because Swiss calc is like.
Oops.
tough.
Sorry.
It's so dead.
What?
Don't worry about it. There's only a little more talking and the class is done.
Oh, so you use the quotient.
So this, think
Finally,
of
we had a
this as
challenge.
f of x. Think
Okay.
of this as g of x.
Okay.
So f prime of x, and then when you're trying to find f prime of x, you have to do the chain.
Oh,
So
I
F-
see.
So what's f prime?
Oh, I think I get it now.
You know what? She didn't learn that from me. She learned that from Mr. House's class.
So basically,
Oh.
I think like you should just underline all the stuff, like,
Okay.
and then just bring it all forward, and then whatever you get here, you just input them.
Mr. Do you want hydrating mist?
I don't, but I can't tell if that's the real stuff or some other homemade stuff.
No, it's actually it's Tatcha.
Okay.
No, it's actually what's it called? Soluble cocaine.
What?
This is white, you know? Cocaine, water, nice hydrating mist.
Exhibition game, no need to show up.
No, they just, I don't blame you for it.
And then you
Game Hudson's telling me to say, I don't
the
think I
derivative
need to show up.
of this guy.
Although it's funny, I don't think I can really use that.
Oh, I see.
Glad you're not running that account, yeah.
Is
The superior doing the other school, 600 kids is gonna take on the school of 2,500.
okay.
You know what I'm saying? We don't personally give everyone
We all know
$8.
who's the superior.
No, I don't, that's so crazy.
Times.
Just say, Hollywood Field on
Any
Heroes will be
Instagram
taking on
caption
Angela.
is great.
Then put the time in the day. Two people.
Times
Oh, yeah,
f
just
prime x.
Show up and show your support at this time.
Mr. Dean, I have a question.
Yeah.
Why did we not stop after this, and why did we find that? Just wanted to say that.
The quick answer is we never took the derivative of the inside function. The inside function is really extra.
Oh, so you just keep going until you get the inside function?
Yeah.
Oh, okay.
Both outside and inside.
I don't understand this part. When we did the question was like, no, there was like x to the 4, but then there was something else after it. This one. Yeah. Why did we take out? Why didn't we do?
Because you're taking the derivative of this right here.
Yeah.
That's that right there. F prime.
But why are we taking the derivative like this? Because then this is like a level down.
Well, because this is your outside function, right? You have to compare that first.
Yeah.
And then you can do the second.
Yeah. But then wouldn't it be like the derivative of this and then the derivative of that? With more inside.
No, but you know, outside and inside. So you take care of the outside first, right? And then all of this.
Yeah, I get it.
Don't test.
I just,
It's order.
Yeah, I understand the 2x.
like, I don't understand why you don't throw the 2x around here.
Oh.
Like, I don't understand why you
People that, I mean, there's that.
the derivative of that is f prime.
Right, leave alone everything else, right? Times 2x. That's the whole derivative of that. That's the first. That one right there is just right there. So I'd say, it's like, what the tip mark for best I created is ski, kick off the soccer, kick off the. Get rid of that.
Yeah.
So you can do that one easily. If you like. Do you see where this is in the problem? It's really, by a path, this part right here, that one, where it is.
Oh, yeah.
And really that one's over here, right? That one's separate.
Wait, how?
I mean, it doesn't.
Where does
work.
2x come from?
Yeah, I know.
Okay, squared, how do you get?
Alright, so you're taking the root of this.
Wait, what happens to your
So,
Because then I can use the
So-
phone on my.
so what's the root of up
Oh,
here?
yeah, that's true.
Basically, it's a big.
Yeah, just divided by-
Like, I
So you outside first, outside,
know,
so this right here is all of that. And you go to the inside, yeah.
That's so weird.
Because it's different from a power, right? So the one that Hudson's confused about is this, because the outside now is this. The outside over here is this. It's switching, right? Yeah. When I give you that weird convex rotation, the outside's really this part. But when I give you a question like that, the outside's over here. So you guys shift gears between which is the outside and inside functions. And then Hudson's situation is it's happening within the problem where you have to shift out and see what is the inside and outside function.
Well, it was F1.
I don't know, wait, is this
You are taking well, Tristan wants to do the same thing. So you were
I
both in the class. So this class tests around 100 marks.
Literally.
And then you just nailed it.
Something like that.
But you got 5 on the exam.
Yeah.
So that's why you have to do that class. You can get top during the year in the exams.
Like,
Yeah, but then my voice might be terrible.
Well, no, not if you apply to UBC. They give you 96
Yeah,
for 5.
that's okay. Maybe I don't really want to.
Oh, so you don't want to go to UBC.
No, I
And do some driving. You know, you want to go to the Harvard or the
realistic. What if he drives a car around and goes really quickly? Like what is this? Like,
Mr. Yu,
How many questions?
That's a good question.
But like, you know what I mean? Like, you take it like Nobel Prize winning scientist who gets knighted. Sure, that's one thing. You take a Formula One driver who drives fast around the loop and like crashes his car like 3 times a year. Right. That's it. Yeah. Like philanthropy and
Yeah.
shit like that.
All right, Darcy, what is Thomas with your
Thomas, do
design
you like
now?
all
What's he doing for calling right now?
I find
Okay,
it
maybe
really.
us women's
Sports car
UFC.
drivers and athletes, we have no idea what constitutes.
Like more so than the guy.
Has he done that or is it back to school?
Crazy.
I saw the one, I think it was featherweight I saw recently.
Yeah.
All right, Hudson, what's going on?
Blondish,
Oh,
yellowish hair guy.
Hudson, what are your contributions to society?
I don't know, he's
We're not doing that one today, right? That'd be like
I don't know.
We're not doing that one today, right?
Right?
It's too much to do
Other
this
guy
one
was
with
so
this one, just like confuse me.
I feel Dominic the boxing.
Don't worry about it, Amy, we'll get there.
Yeah, like to see that.
That's where the money's at though.
Yeah, we're only like a few fighters, so they make money. Every card makes sense.
It's like knockouts, like having experience, or like even going to the No, I mean, I have the sometimes when I'm driving.
Okay, Calc 12 students, can we come back to the notes here? Now, class, the assessment that I want to do tomorrow for marks, which is worth a bit more than the speed runs. I want to see if students have an understanding of wrapping derivatives. I know we've been doing product rule, chain rule, quotient rule, and all that. I want to go over some ideas with graphing because graphing has to do with more of your understanding of how fast things are changing. And I want to go over a question where I give you f of x right here. And this will be the last thing I'll be talking about for today. And I hope we'll get this done in like 3 minutes. This is f of x, right? And I want you to graph f prime of x, and I want to sketch it. Sketch just means I want a general shape, not the real thing, right? One of the things when you're graphing derivatives, one of the very first techniques that I like to share with students is that you should find the horizontal tangent lines.
What? Can you move it? Which way? This way?
When you have a horizontal tangent
that?
line, Sam, what's the slope?
Horizontal tangent line.
Yeah.
Zero.
Okay, there you go. So when you graph that, when your derivative value is 0, that's really on the x-axis, right? So if I go straight down here, right, I'm graphing the derivative. We should have an x-intercept. Does that kind of sense how I graph the derivative? If the derivative value, if the slope is 0, that means the derivative value is 0, right?
Yeah.
So when x is 2, the slope is 0. So then you should have an x-intercept of 0 at 2, right? Does that kind of make sense? The slope here is 0 when x equals to 2. So when you're at 2, when you're graphing the derivative, you should have an x-intercept of 2, 0. So let's write that back down first. If you have a horizontal tangent line, this means that f prime of x has an x-intercept. So what we're doing is we're graphing its derivative, right? If the derivative has a value of 0, that means the height should be 0. Okay. What I like to do next is this, and this is where it kind of gets a bit weird. I like the ends next. When I want to graph the derivative, I want to look at the ends. What do you notice about the end on this particular graph? It's what's the slope on that end? Right, so can I say this is a negative slope? And this is a positive slope? A positive slope means that over here you should be above the x-axis. Now I'm not sure what it's going to look like, but can I just draw? I just draw this. No, don't draw this. Don't draw this. But I'm going to do something like that. Is that part above the x-axis? Now please don't draw this. Don't draw this. I'm just saying that if you have a positive slope over here, the derivative should be above the x-axis. Okay. If this is a negative slope, the derivative should be below the x-axis. And I wouldn't just draw this yet. Draw at the very end. So maybe it's something like that. I don't know. What do you notice about this slope here? Positive slope, right?
Yeah.
Can you turn it to where he's drawing? I can't see anything.
Can you see it now? Do you want me to move it?
So that blue part's a positive slope, right?
Can you see it?
Maybe it's frozen. Never mind.
See it?
So class, this blue part right here, is that a positive slope? So I'm just going to argue that in this region, we should be above or below the x-axis? Above. Now, the slope here is what? 0. And then it starts to increase, but then it goes back to 0. So the slope is 0. We increase, but then we go back to 0. So